Hi, I'm Dr. Savic, and today we will talk about scalars and vectors. You probably heard about scalars and vectors before. Examples for scalars, we are talking about mass and volume. Characteristics, the scalar has a magnitude, positive or negative. For addition, we are using simple arithmetic rule, and there is no special notation. But when we are talking about vectors, the examples are force and velocity. Characteristic of vector has a magnitude and direction. If we want to add two vectors, we are using parallelogram law or triangle law, and special notation, we are using bold font, a line, an arrow, or a caret. So vector operations, we have scalar multiplication and division. If a vector is multiplied or divided by a positive scalar, its magnitude is changed by that amount. Multiplying or dividing by a negative scalar will also change the directional sense of the vector. So if we have two vectors, for instance, vector A and vector B, which are given in figure A, and we need to find the resultant of the two, what we will do first? Firstly, we need to join the tails of the components at a point to make them concurrent. Then, from the head of B, we need to draw a line parallel to A. Then we need to draw another line from the head of A that is parallel to B. These two lines intersect at point P to form the adjacent sides of a parallelogram. The diagonal of this parallelogram that extends to P forms R, which then represent the resultant vector R, which is equal A plus B. So this is the vector addition parallelogram law. We have also triangle method. Again, we are putting both of them together, vector A and vector B. And the rule here, we are always adding tip to tail. So this is the triangle rule in order to obtain the resultant force. Vector subtraction, the resultant of the difference between the two vectors A and B of the same time may be expressed as R is equal A minus B, or it is equal A plus minus B, which means we need to change the direction of the vector B. So subtraction is therefore defined as a special case of addition, so the rules of vector addition also apply to vector subtraction. The only difference is we need to change the direction of the vector B. So the same rule. We are using the same starting point. We are using parallel sides to the vector A and vector B, and the resultant force will be the diagonal between vectors A and B. Vector additional force. Experimental evidence has shown that a force is a vector quantity since it has a specified magnitude, direction, and sense, and it adds according to the parallelogram law. So if we have some forces F1 and F2, and we need to find the resultant force, we are using the rule which we already saw, parallelogram law, in order to obtain resultant force in a figure shown, figure B. If we have triangle law, tip to tail rule, then we will have figure C. So FR will be F1 plus F2. So what if we need to find the components of force? So before we were talking about resultant force. Now we have resultant force, but we need to find the components, for instance here in the directions U and V. So in order to determine the magnitude of each component, again a parallelogram is constructed first by drawing lines starting from the tip of F, one line parallel to U and the other line parallel to V. So these lines intersect the V and U axis, forming a parallelogram. The force components Fu and Fv are established by simply joining them to the tail of f to the intersection points on the u and v axis. This parallelogram can be reduced to a triangle, which represents the triangle rule. From this, the law of sines can be applied in order to determine the unknown magnitudes of the components. So we have one example. If we have a screw subjected to two forces, F1 with 100 Newton magnitude and F2 with 150 Newton, and we have angles 15 to the x-axis and 10 degrees to the y-axis, we need to determine the resultant force. So how we will do this? If we are using the parallelogram law, then we need to obtain the angles between the two forces, F1 and F2. So since that we have 10 degrees from F2 to the y-axis and we have 15 degrees from the F1 to the x-axis, that means that this angle between F1 and F2 is 90 degrees minus 10 minus 15, which will give us 65 degrees. So if we have 65 degrees between F1 and F2, that means that at point A we have also 65 degrees. Parallelogram has 360 degrees. That means that we will have the rest of the angle to be 230 divided by 2, which will give us the angles of 115. So if we have this one, we have 115 angle, we have a force of 100 Newton, we have 15 degrees from force F1 to the x-axis, and we have 150 Newton for the F2 force. We need to find the resultant force and we need to find the angle phi. So how we can do it? From the parallelogram, the vector triangle is constructed. We are using the law of cosines. So Fr will be square root of 100 Newton on square, which will be our force. Then we have plus 150 Newton of square, that is the second force, minus 2 times 100 times 150, and we have the angle of 115 between the forces, cosine of 115. All of this under square root will give us the value of 212.6 Newton, and that is very close to 213 Newton. So this was the example how to determine the resultant force if you are using parallelogram law and the cosine law. So these were the scalars and vectors, and we will talk about Cartesian vectors next time. Thank you for your attention, and if you like the videos, you can hit subscribe.